to Plus Day. I am Trace. This is episode 5 of 5 in our crazy episodes on light. This series has been kind of mind-bending, for sure. I hope you've listened and watched the entire series. Make sure you go all the way back and find out how light works and what it is and how it affects humans and how we observe it, if we observe it at all, and if we observe it, how it changes. All of those things we've talked about. Today, we're going to follow up yesterday's episode about the speed of light and talk about stopping it. Stopping it in its tracks. We use light for all sorts of things, and we call it lasers. Lasers are used for cutting things and for signaling, for communications. Of course, it's not really cutting things. You know, they're shooting photons, and when they hit atoms, they excite them by imparting their energy on them, and that causes them to kind of rip apart on their own. But we also use them for warfare, where we can use them to shoot low-power infrared lasers to blind heat-seeking missiles, or to, blow up things by heating them up. It's kind of the same idea, just on a larger scale. But that actually isn't really anything. Although if you want to see a really cool one, the Navy has a 30-kilowatt laser weapon system. We'll put a link in the description when we were researching this. It's crazy. It's basically a giant laser cannon, but I digress. In 1999, we did the opposite of using lasers in communications and for cutting things and for blinding heat-seeking missiles. We completely stopped it. And we did it for a lot of different reasons, which we'll get to. Researchers at Harvard University in '99 slowed a beam of light down from 186,000 miles per second to 38 miles an hour. That's slower than a greyhound, faster than a speeding house cat, but, not by actually that much. They did this by passing it through what they called a Bose-Einstein condensate. The Bose-Einstein condensate is basically a cloud of subatomic particles that has zero spin, which in quantum speak is essentially a boson. You've probably heard of the Higgs boson. That is one of those type of subatomic particles. They cooled this condensate to just above absolute zero so that those particles weren't moving. The atoms of the condensate were essentially still, or as still as we can get them without going to absolute zero, at about 0.15 Kelvin. Now, if you're a physics student, you probably already know this, but under these conditions, the bosons occupy the lowest quantum state. The macroscopic quantum phenomena become apparent. Now, for you and me, the people that aren't physicists, basically, we're observing photons in a way we weren't supposed to be able to do based on theories of quantum mechanics because we've cooled this condensate down so much. We're basically altering how it works. Now, if you send a beam of light through that condensate, it travels 20 million times slower than normal, but still passes through it. In 2001, the same team advanced their experiment and were able to completely stop light for 1/1000th of a second, which might not seem like a lot, but that's a lot in the speed of light. We have cameras that can shoot frames faster than 1/1000th of a second. I mean, that's an eternity when you compare it to the speed of light. In 2013, researchers kept light still, completely stationary, for 16 seconds using cold atoms. And how this one works is super cool. They took an opaque crystal, a crystal you couldn't see through, but they fired lasers into it. Those lasers were at specific wavelengths to resonate and disturb quantum states of the atoms inside the crystals. By creating two quantum states in those atoms, they made the material transparent to a specific frequency range of light. This was all very precise. Then, they shot another laser beam at that specific frequency range into the crystal through the newly transparent region, turned off the other lasers, making the thing opaque again, and trapping that little bit of photonic energy inside of the crystal for a whole minute. That's insane, right? I mean, if you've been through this whole series with us, you know that that's crazy, that they were able to take something that's a particle, that's a wave, that's a massless piece of energy that never decays, and they were able to stop it inside of a crystal using just laser energy. So if we know the speed of light is constant in the universe, and it's the fastest thing around, what's the benefit of stopping light? Like, what, other than it looks cool to have a crystal filled with light not moving, what's the benefit of stopping it? Professor Thomas Halfman at Darmstadt University in Congress with those Harvard researchers, they were able to store and retrieve an image consisting of 3 stripes inside of that crystal. Researcher Georg Heinz said, "We showed you can imprint complex information on a light beam and then stop it to store it." That means we could send data encrypted on a light beam anywhere in the universe. Plus, if we can figure out quantum entanglement and quantum mechanics, then we could create, using information encoded in light, a quantum internet. This would mean that we could create more powerful computers called, quantum computing. We could have better digital security because you'd have to be able to stop that light and then decode the information. And using that technology, we might be able to create a quantum internet. You get to say quantum internet if we figure this out. I mean, that's pretty cool. If we figure out quantum computing, which is essentially saying we're going to use these little pieces of subatomic energy instead of transistors and silicon and chips, then we could have super powerful machines that could communicate across vast distances of space instantaneously. Imagine a person on Mars with a quantum communicator. They could possibly communicate easily with us at home, maybe even in real time. These are things that, if we can understand light better, the stuff that bounces off baseballs and our eyeballs, we could potentially change all of human society in the same way that it changed when we first came about with fire. Light gives us so many things. It can be used to destroy things. We can use it to communicate with other people. We can use it to send messages now, just, writing it down and having it reflected so that you can pick it up with your fovea centralis. But without light, the future would sure be a dark place, pun intended, but also no pun intended. Thanks for watching Test Tube Plus, everyone. I hope you enjoyed this series on light. Let us know down in the comments how you